Namaskar, ma'am.
Before we start today's Maths Chintan, let me just introduce each of our panelists and guests today. We have Dr. T.V. Venkatesh with us. He is a senior scientist in the Vigyan Prasad Department of Science and Technology, and he is actually working on the creative side of the mathematics, I can say this. More we will be hearing from him. We have with us Dr. D.K. Pandey. He's former principal, NC Jindal Public School, and now is director and advisor to the Kamal Group of Institutions. We have third panelist today with us, Khushbu Goyal. She has joined, I can see.
Yeah.
Khushbu is working as quality control manager with the Whitehead Junior. We have Dr. Dharam Prakash ji with us. He's a retired professor from NCERT, and also other eminent mathematics teachers, educators. I welcome you all. So for past few days, we have started this informal...
Let me interrupt Anita ji.
Ji.
And Anita ji ko main introduce kar deta hu. Anita is the driving force. Whenever you give some ideas, she starts putting them into implementation. So she is the driving force behind this Maths Chintan. And she will explain what exactly we mean by Maths Chintan.
Oh, this Devaraj is from Kerala.
Yeah.
Yes, sir. Yes, sir.
Namaskaram. Sugadanne.
Namaskar.
Yeah.
Namaskar, Devaraj ji.
Namaste.
So the idea behind this whole Maths Chintan is कि चिंता को छोड़ करके थोड़ा चिंतन किया जाए. मैथ्स का जहां पर नाम आता है सामने, तो थोड़ा डर, थोड़ा फियर, परफॉर्मेंसेस, अचीवमेंट, मार्क्स स्कोर कर पा रहे हैं, नहीं कर पा रहे हैं, वो वाली चिंताएं जरा ज्यादा हो जाती हैं. तो मुझे लगता है कि उस चिंता को छोड़ करके अब हमें थोड़ा ये सोचने की जरूरत है कि हम समय के उस दौर में हैं जहां पर डिजिटलाइजेशन बहुत तेजी से हो रहा है, ग्लोबलाइजेशन हो रहा है, और इंडिया खुद अपनी जो है यंग तो हो ही चुका है. हमारी 75th इंडिपेंडेंस एनिवर्सरी हम सेलिब्रेट कर रहे हैं, लेकिन आगे जो नेक्स्ट 25 इयर्स हैं वो हमारे कैसे होने चाहिए, कैसे होने वाले होंगे, उसके लिए अभी से थोड़ा सोचने की जरूरत है कि मैथमेटिक्स हमको कैसे फ्यूचर रेडी कर रहा है. आर वी प्रिपेयर्ड फॉर द न्यू इमर्जिंग नॉलेज डोमेन्स which are based on the mathematics? Are we prepared for the future world? We all know that there are so many challenges. We were prepared in some way for the sudden challenge which emerged due to the COVID, लेकिन अब आगे आने वाले challenges और कैसे होंगे पता नहीं. तो वो सब कुछ देखते हुए जो मैथमेटिक्स हम पढ़ रहे हैं, because we always say that mathematics is queen of all sciences, हर सब्जेक्ट का बेस है. तो मैथमेटिक्स करिकुलम में कैसे चेंज होने चाहिए, किस तरह के स्टूडेंट्स को हम प्रिपेयर करना चाहते हैं. अगर हम अपने समय की बात करें, मुझे लगता है यहाँ पर कम से कम 3 जनरेशंस तो हैं ही. मैं और डॉक्टर धर्म प्रकाश सर जिस समय के पढ़े हुए हैं, उस समय हमने जो कंटेंट पढ़ा वही शायद हमने अपने स्टूडेंट्स को पढ़ाया, और आगे जो नेक्स्ट जनरेशन है वो भी वही कंटेंट पढ़ रही है. तो इससे जो नेक्स्ट आने वाली जनरेशन है उसके लिए कैसे चेंजेस है, उसके ऊपर थोड़ा विचार मंथन करने की जरूरत है. तो इसलिए आजकल हम लोग हर शाम 1 घंटा बैठते हैं, ब्रेनस्टॉर्मिंग करते हैं. ये फॉर्मल डिस्कशंस नहीं है, लेकिन ये इनफॉर्मल डिस्कशंस है, क्योंकि हम सबके अपने अपने एक्सपीरियंसेस हैं. टीचिंग लर्निंग के एक्सपीरियंसेस भी हैं, मैथमेटिक्स के साथ भी हमारे एक्सपीरियंसेस हैं. तो उन एक्सपीरियंसेस की लाइट में हमारी अपनी क्या फीलिंग्स हैं, क्या सोच है कि कैसा मैथमेटिक्स होना चाहिए, तो यही डिस्कशन हम करेंगे. सो आई वुड लाइक टू स्टार्ट विद डॉक्टर वेंकटेश. Sir, I would like to know from you, first of all, you tell us that what do you feel that how much is the need of mathematics in the coming world? Because the students somewhere they have this feeling that there is no need to learn mathematics for everything. The calculator is available and the softwares are available and the apps are available. So what is the need of learning to solve problems? and to attempt problems. So what is your opinion about this?
Yeah, okay. So, I mean, one can look at this question from two levels. One, what I might call as the pedestrian level. Okay, like there were many people. I mean, there are films where people ask this question that your maths teacher comes and teaches me mathematics. Your physics teacher comes and teaches me physics, but they expect me to know everything. I mean, this kind of a pedestrian or a very what I might call as rhetorically sounding nice, but lacking substance. You know, that kind of criticism is that. Let's keep it away. I don't think we are engaging with it. Let's keep that away. If we ask the question that let's think that the world is changing. In this changing world, what kind of maths education we should be working towards or think towards, so that the child which is entering into the school today, when the child comes out after 20 years or 15 years, the child is prepared to meet the world that which will be emerging before her. If we ask that kind of a question, sure, we need to do a very deep introspection, rethink. That I am very clear. Why? Let's look at a very summary look at the history of maths education per se. Like when I was in school, that is when I was coming into the high school, sixth, that is when this so-called new mathematics was introduced. Everyone was talking about this new mathematics, saying that new mathematics is the future. In India, we are lacking, and the Tamil Nadu government jumped into it. You know, all those kinds of things happened. So some idea about set, you know, this kind of stuff came in from moving away from the earlier emphasis on the traditional maths curriculum of, you know, profit calculation, interest calculation, mensuration. You know, these things were slightly taken away, and then this new mathematics like, you know, set theory and all these kinds of things came in. Of course, algebra, geometry were there. They also saw a bit of a difference. Algebra became slightly more modern algebra. You know, that kind of things happen. In the same way, I think today we need to look at what is the kind of new world that is emerging. What should the school education do for it? So when you look at science, maths education, we are looking at from a libertarian point of view of education, not purely you know, utilitarian point of view, but we are thinking that education should make a person full round up developed person. You know, if we have that basis to start to discuss, then both maths education and science education need to do two things. One is what would be traditionally seen by a lot of people as science education, maths education. That is some information about science and maths, some, let's say, knowledge about science and maths. But we also need education about science, not just in science. Similarly, we also need now education about maths, not just in maths. That part, I think, will require a very serious thought. So if you look at the range of issues which are there in the contemporary world, with the emergence of social media and social media becoming ubiquitous, old people like us may not be so much engrossed in social media. But look at young generation, look at the statistics, even in India, a country like India, which is a poor, not so developed country, and so on and so forth. The penetration of social media is rapid, incisive. So given that, and young children are exposed to this social media, issues like, say, for example, how do you judge a claim? When some claim is made that the vaccines are dangerous, okay, vaccines cause death. Let's look at science and maths related. Forget about the political and that kind of stuff. That's a different issue. So we do routinely get such messages, right? I mean, almost every month I certainly get one message which says that Tulasi produces ozone. Ozone is good for the world. So grow 18 Tulasis. If we all grow 18 Tulasis, then the world will be free of pollution. one fundamental problem is that if there is ozone at the ground level and we breathe ozone, we will die of cancer. Ozone at 50 kilometers away is good, but ozone at ground level is cancerous. So how do you judge these kinds of claims? This is one important challenge. So scientific method, the method of science becomes very important. The next is mathematics. When people make a claim with the numbers, okay. So the question comes in, what is the mathematical models which are used to make this prediction? So predictions like fourth wave is going to come, or third wave will not come. These kind of claims are mathematics based, right? So what is the model that goes behind it? So here I'm not really talking about maths in the traditional sense of calculating, dividing, subtracting, or even doing some amount of theorem proving. But here I'm talking about how do I use maths to analyze a real life problem, what kind of models I'm getting into, and so on. So this particular area is going to become an important challenge, given the fact that we are also moving to a situation where the fourth industrial revolution is becoming stronger and sturdier. Artificial intelligence is all around us, right? Algorithms are in a way ruling us in various ways, and algorithms are actually mathematics, right? So if we have to understand about algorithm, not only on algorithm learning, about algorithms are also required. I think from this point of view, I certainly feel that we need a real relook.
Overall, you want to say?
Yeah. There is a need to relook at what kind of maths we will teach, how we will teach, what will we emphasize. I think we need to look at that. Same way, science also needs a relook.
That means we shall address two questions very pertinently. That one is that what kind of content and what shall be the approach of teaching mathematics. Because if we want them to be the good analyzers, we teach them problem solving, but then we teach them the specific kind of problems to be solved, which are given behind the textbook and not otherwise.
And they are very neat and clean, no fuzzy edge. The problems don't have ifs and buts.
No. So how that approach can be introduced in the school? How we can bring that in?
Yeah, I mean, one is, for example, are we how much of logic we are thinking? I mean, as a historian of science, when I look at, for example, maths teaching in, let's say, early 20th century or late 19th century, there was a great emphasis on logic. Okay, logic was part of maths, and mathematics taught logic, logical fallacy, and so many other things. I mean, yeah, of course, nowadays, I mean, in a higher mathematics, you may learn a little bit about, let's say, predictive calculus and things of that kind, but not in school. I mean, logic is not part of the school. But now, if you are going to look at the emerging world, any statement, you'll have to arrange it in a logical order. Okay, if then else, all this kind of operators, you should be familiar. That's something that is going to be a very important skill if we talk only from skill aspect, not perception, only a skill aspect. So how are we? I mean, so then this provides us a neat, lovely opportunity to present maths in a particular way, right? So right from even early ages. I mean, it's not only in higher classes, even in elementary education, certain kinds of logics are certainly, talkable, debatable, learnable. Certainly, I think many people need to put their head, but I can see pointers. I won't say that I have a very well worked out plan right before me. That's impossible. I mean, if anybody claims that, I think we should be very suspicious of it.
No, we are actually just raising the questions, and I think in raising the questions, somewhere we will be able to find the answers also. So
yeah, one thing I want to also add. Sorry, I mean that was what was slipping in my mind. it is not about children sitting next to a computer.
Yeah.
Many people think that I should have the most powerful computer and make the children sit. No, it's not about that at all. In fact, if you look at some of the handbooks like Computers Unplugged, okay, they are the kind of things that actually make you think about maths or mathematically think things around. So it is not about computers per se. Computers are not bad. I mean, it need not be eliminated. But this part we need to understand, because most people think that it's about infrastructure. So it's not actually about infrastructure.
Yeah. I want to ask another question, pop up another question, TVV, that we need to, as you said, relook or overhaul the curriculum, change the way it is being taught. I'll start with a small example that in 2005 or 6, when we were doing books for primary in NCERT, we started thinking about it, and we realized that patterns and rule making, data handling are going to be very, very important. So we started, in spite of lots of protests from various angles, we put them in the primary classes.
Yeah.
Data handling was not there before, but data handling came in. Similarly, patterns and rule making, very low level, but we did introduce that particular thing in primary. So if I ask each of the panelists here, even Dr. Pandey, Khushbu, and you, to peep into future, what are the topics or what are the content which will be, could be useful 10 years hence? Could you just think aloud? And
okay, see, there are, like, for example, any language, you certainly needs to learn the alphabet. You certainly need to learn certain grammar. Okay, so whatever be the time and age, that's not going to change. In the same way, even in maths, for example, few things like, say, for example, number, positional number, some of these things are going to be, they are going to endure. They are not going to go away. Okay, so, but keeping that aside, if I look at the maths education from first standard to 12th standard, so in the first standard, I'm 30,000 years ago, what maths people were doing in the world, I'm doing maths in the first year. In the second year, maybe I'm coming to 15,000 years ago, what people were doing maths, I'm doing maths. Okay, so if you come to maybe 11th and 12th standard, maybe I come to 18th century or maybe little bit of 19th century. Right? So that's how our maths curriculum is. Maths curriculum is because we think that maths is very structured, logical. We order the curriculum also in the same way. But science is not like that. Remember, in the first standard itself, you study that Earth is going around the sun. You may not even study Ptolemy and all that. I mean, you may study it much later, right? So slightly a more practical approach is the science on, good reason, bad reason it is doing. But maths, because we are all maths enthusiasts and we cannot compromise, we all ensure that the ordering of subjects is like this. But let's look at maths around us. The way, for example, a mobile phone shift from one tower to another tower is linked to 4-color problem.
Yeah.
Can we talk this in maths class? Maybe not in second standard, but certainly I think 6th standard, 7th standard students should be able to understand this. So you don't need to talk about, let's say, the 4-color theorem or topology only in BSc first year or second year. No, I mean, you don't need to. If we imaginatively think, it's possible that we can relook at the math. This is what I'm saying, that we need a de novo relook at the maths. There will be some core which will be common. We cannot, because they're all skills, right? I mean, computing skills, calculating skills. Even if you are going to use calculator, little bit of knowing how to add 2 numbers is needed. I mean, how much drilling you may need it in a contemporary time is a different issue. But knowing that how to add 2 numbers or how to subtract 2 numbers, some fundamental thing will be certainly required. It's like learning the alphabets in any language.
Okay, Dr. Pandey, how would you respond?
Yes, sir. Thank you very much. I very much agree with Dr. Venkatesh that those things which are fundamental has to remain there, because alphabets can't be changed if you have to learn a language. However, I believe that whenever we sit for curriculum and we look at the future citizens, we understand that everything has to be revisited every now and then in contextual environment where you have to see other subjects improving or modified. Mathematics has to modify. In fact, whenever we were sitting in the classroom, still we find a teacher taking the example of number. I just asked them to introduce how you will introduce 5 to a pre-nursery or nursery or prep children. They just take their finger and they show it to us. And this is the traditional method, as Dr. Venkatesh has said, that what our forefathers had learned, the same methodology is being employed. Hence, as sir, you have asked me to foresee the coming 10 or 20 or coming generation, how mathematics has to restructured, I will simply say that it has to be relooked from the application viewpoint. And being a student of physics, I can understand that mathematics has to be there to help us shape a better life. As computers and mobile, they have come here to stay. I understand. Am I audible, sir?
Yeah.
Am I audible?
Yes,
Yeah.
please.
So all this mobile and computers and their programming, all these things have to have their time. If we remember our childhood, we did not have that facility what this generation or the future generation students will be having. So keeping mathematics in the old pattern will certainly make it more boring. As such, mathematics, when we say I am your maths teacher or this is your maths period and things start shivering, that has to be relooked. So it is the methodology which needs to be improved more than the text material. And there I will always stand for searching, applying, and exploring the new methodology of teaching the same addition, multiplication, subtraction, or calculus or algebra. And I will always advise that it has to be contextualized in the form of mathematics lab, which has already been introduced by the NEP 1986, National Education Policy, or the new education policy, what we say. And now it is being modified further, brought all vocational services and industries nearer to the school. So NEP 2020 has to be followed in toto, keeping the requirement of future generation commensurated with the teaching of mathematics. This is what I feel, and we all will have to put our heads down together, especially our mathematics teachers, that methodology has to be improved upon than the context. Thank you, sir.
Dr. Pandey, I want to understand one thing from you, because you say that methodology definitely requires a change. So we now talk about the challenge-based approach to teach mathematics, or for that matter, any subject. Since your background is physics, would you like to share with us some problem of physics, maybe from any other discipline of the science, or from the physics, where the child has to explore certain mathematical facts or concepts in order to solve that problem? So how the student shall approach towards that problem while learning the concepts which are applicable from the field of mathematics to that problem?
This is very pertinent question you have asked, madam. Here I will just mention one small thing, that Professor Lawrence from physics or Professor Dirac, they were better mathematicians than the physicists. And if we all understand, theory of relativity was given to us in 1905. Until 1919, no mathematics were generated to give the concept of Albert Einstein. So this is where I am using this example. It is a very pertinent example that how mathematics was developed later on, and the experimentation was never thought over until unless it was 1919. But it was the genius of Albert Einstein who could correlate the things, and he could tell us about the bending of light, which was only proved when theory of relativity was established. And Professor Lawrence then later on gave rise to the mathematics behind the special theory of relativity. And general theory of relativity is more to mathematics than to physics. You will be understanding it much better. And this is how we have to understand that concept and conceptualization should not be followed by the natural logical end of mathematics. Rather, mathematics has to be followed by the concepts, because concepts are more intuitional, and it has to be thought over according to. So students should be thrown with the challenges and let them have the habit of developing mathematics behind whatever they have been given. Any example you take, suppose simple lever. So first they have to learn about how it is happening, and then they should be followed by the mathematics would have been an excellent understanding, and it will be more interesting, and it will be just taken away. The boredom can be taken away from the classroom teaching of classical methodology in mathematics.
But I think our teachers, they need training, and they shall sit with the other department teachers. Only then this kind of learning can be brought in the
One
classroom.
small example, I will take Pythagoras theorem.
Mm.
The students are given in the lab, and then they are given the 2, 3 squares. And once they are added to it, then a plus b whole square is understood very well. All these things are the practical things which is done in mathematics lab. And once it is done, concepts become very clear. And as Dr. Venkatesh has said, we cannot take away the beauty of computer, like giving the concept of third three-dimensional figure. Why I am using all these words? Because it is more relevant to physics side. And you will understand that whatever things we see around, they are all three-dimensionals. And when we have to add the fourth dimension, human mind fails. This is what exactly happened in the times of Einstein. Einstein used to have the time as its fourth dimension. But all over in our experiential life, whatever we could experience, we could not imagine beyond 3 dimensions. And this, when we are teaching in the classroom and you do not have any supporting material, then you see the whiteboard or blackboard, it is 2-dimensional. Now you are making a cube, and this angle, if you really you measure it, it becomes 120 degree in place of 90 degree. And we keep telling students that think in your mind, 2 lines are 90 degree and third line is 90 degree to these two both. And we have to give some physical example. Now, if only board is there and you have nothing, how you will bring this concept? A child who is average or below average, he will always measure that angle and he will get it 120 degree. He will never get it 90 degree. And then he gets confused. And how, when you are making a projection, suppose a vector projection for a 3-dimensional figure is done, as we are doing it, our vector algebra of 3-dimensional, when cross product I have to make children understand. Then cross product, making them understand, we have to give all sorts of acting along with the two-dimensional blackboard. So all these things, I have to go to the door of the classroom. I have to make the use of hinges, and then I have to make the children how it is moving. And then we have to make the understanding that how the third force in the direction of movement is perpendicular to the two dimensions where from forces are coming. All these concepts make children very much confused, and that is why they start escaping away from too much understanding. So all this, if we give them physical example first, and then we give mathematics later on, I understand mathematics will be a lot more interesting than what it has to or it used to be in our days.
मैथमेटिक्स को एज एन इंडिपेंडेंट सब्जेक्ट पढ़ाने की जरूरत है या ये इंटीग्रेटेड अप्रोच के साथ ही इमर्ज होना चाहिए या
मैडम अगर इंटरेस्टिंग
introduce होना
बनाना
चाहिए?
है तो you have to bring life into it. This is my I may be wrong because you all are mathematics experts sitting and you must be laughing at me that I might be looking at times irrelevant. But since as a physics student I have realized my limitations, that to think of beyond certain things becomes abstract, and this abstraction and concept and logic and estimation, all these things makes mathematics more burdensome than it used to be in general.
So we have Khushbu with us. Khushbu, you have a very different kind of experiences because you have been associated with various organizations in the capacity of content developer, and now you are with Whitehead Junior. What do you feel that how the approach which are being used in writing the contents nowadays is different from the for the content writing which is done for the textbook?
Right. Thank you. First of all, I would like to thank Anita ji and DP sir for inviting me for this discussion. And it's really valuable suggestions from Dr. Venkatesh and Dr. Pandey ji, what they have shared. I would like to share, see, I was from the background where I have always supported hands-on learning. And that is what I have utilized in my teacher training programs also. But this pandemic has given us some different scenario where we have to, continue the education. At the same time, we are from the thought we should not, drop the idea of conceptual teaching. And with Whitehead Junior, I have observed that yes, hands-on activities, we can't go at home, we can't have face-to-face children, but we try to digitalize hands-on experience in our classes. And frankly speaking, I had conversation with many parents. As we know, in India, our teachers are not prepared for such kind of approaches. Many teachers are not aware of such approaches, and that's why they lack. It's not their fault because they have learned in those traditional way only. That's why they could not implement. When I interacted with parents, they realized that maths classes with such kind of approach is really helpful for students, and students are able to improve their performance in mathematics. I would like to come back to a point where you started, Anita ji, asking ki, since computers are there, so should we not have mathematics as a subject, or calculators are there, so whether that is required or not. I think one myth is that we always relate mathematics with numbers and calculation. We need to think in a broader aspect. Mathematics is about logical thinking. Mathematics is about looking at shapes and many other things in our real life scenario, right? Even to make a calculator, you need understanding of mathematics. You can't write any programming without learning mathematics. So what we do whenever we create any complex problem for our class, teacher thinks, let me complicate the numbers. I think complicating the numbers for calculation is not the solve. We need to complicate the logic. We need to bring logic in our problems. We need to bring real life problem in our classes so that students solve that. For example, I'll take very simple example. For example, we need tiling for a floor. What do? Do we just have one problem in our life to solve, or do we, look at various options and then decide what should I choose? So I think such kind of scenario we need to bring in our class, asking student to do a project kind of work. Okay, this is the room. You are supposed to do tiling for this room. Now find out how many tiles are required, what is the price of the tile, and which one will you choose. So they need to figure out the pricing. They need to figure out what number of tiles is required, what is the costing, and what is the best to choose. And they need to justify their choice. There's nothing right and wrong. It's all about the efforts they are putting in and whatever logical conclusion they bring. They may choose the costlier one because they love the design, that one. So I think such kind of mathematics is important to bring in our class, which student will enjoy also. Student will relate with real life also, and student will learn gradually. Second thing, when we talk about how should we teach, I feel we should bring blended kind of approach. Till primary, we should focus on all these, experiences kind of thing. But gradually from 6 onwards, a little bit of integration of computer is also good. For example, if I talk about making a bill, right now we all know most of the stores have computers to make the bill, right? Why not making the bill on Excel? Why students don't put formula and create some template on the Excel? So if you, there's one game, World Trade, those who have small kids might have seen. If we remember our time, Monopoly or some trading kind of game used to be with paper currency. But now games are also evolving. They are coming with, swapping machine and cards. So that way we also need to evolve our mathematics in our classroom.
Absolutely right. So we need to see that how we can help the students to understand the problems in the context, and then we should also be able to evolve. I am observing that for past many years, a list of project is moving from one school to another school, and from one place to another place, from one year to another year. So how the new projects can be thought of? Are we helping the children to think about the new problems while going through the current situations, maybe while reading the newspaper or some article or some magazine or some current affair? For example, Dr. Venkatesh has given very interesting examples कि रोज किसी ना किसी तरह का क्लेम आता है, जो उन्होंने तुलसी का एग्जाम्पल दिया या उन्होंने फोर्थ वेव का एग्जाम्पल दिया. इस तरह की जो मॉडलिंग प्रॉब्लम्स हैं वो उसका एक्सपोजर आई थिंक स्टूडेंट्स को देना बहुत जरूरी है, और वो हम कैसे दे सकते हैं ये सोचने की जरूरत है. आई वांट टू कम बैक टू डॉक्टर वेंकटेश सर. आजकल ये कहा जा रहा है कि मैथमेटिक्स 3 डायमेंशन में जरूरी है. वन इज मैथमेटिक्स फॉर लाइफ, देन मैथमेटिक्स विच इज रिक्वायर्ड एट वर्क प्लेस, and the mathematics to understand the science and technology to make the base for that. So what do you feel that do we require different kind of mathematics for the students who are going to join the further streams or the careers which are based on the STEM, or the students which are going to the streams which are not based on the STEM?
Okay, increasingly the society is becoming mathematized. Whether you know it, whether you don't know it, it is happening all around us. Okay, the moment you start using app, there is some kind of algorithm which is working, which is doing things. So how far you are going to take it as a last word, or are you going to reject it completely? All these are all judgment that we need to make. So if I say for the mathematics for future world, rather I would say that 2 types of mathematics is required. One is what we might call as math skill plus math thinking. That is one part. The second is the social aspect of mathematics. Okay, mathematics taken in a very large sense, a broad sense, the social dimension of mathematics. Because increasingly that issue is going to also emerge as a challenge. Because now when you say workplace, well, we are not there, but we are heading there. I'm sure many people who are there in this program itself, earlier you had a home and a workplace. Today, both are same. For most of the people, there is no work. For example, if you take a Swiggy driver, what is the workplace? Motorbike, right? So the traditional frames of work is changing drastically. Still, for example, there'll be a miner who will go to a mine and mine. I'm not saying that will be completely eliminated, but the numbers are dwindling. The numbers are dwindling. So looking at from that point of view, the nature of work, everything is going to change. So the traditional idea of work, home, all those things are blurring now. So we need to keep that in mind. And before we proceed further, can I share a screen and then show something? I mean,
Sure,
will
sir.
it be permitted?
Yes. Just a minute. Shall I make you the co-host?
Yeah. No, I'm able to share. It's okay.
Okay.
Now I'm able
When
to.
you click on share screen, there should be one icon.
Yeah. Can you see my screen now?
Yeah.
Yes.
Yeah.
Okay. So now when you look at, for example, artificial intelligence or machine learning or deep learning, feature extraction is one important aspect, right? So here is a children's book, which is talking about feature extraction. Yeah. So it is not only talking about feature extraction, it's also saying that how do you classify them?
Okay.
Can you see that graph on the other side?
Yes.
Ear shape, snout
Yes.
length. That is, you are taking two features and then making a graph. Of course, if you take more features, I mean, it has to be n dimension, which is not possible. So they are doing it in 2 dimension, just to give a feel of what exactly is happening. Now, look here. So now you have a new picture. So where do I put that picture? So that is, where do I classify them? I mean, some important aspects of, for example, machine learning.
Yes.
In a very interesting way, they are putting it out. Can we develop this into an activity? So today, I'm sorry to say, I mean, maybe I'm making it rhetorically sharp just for us to be shaken up.
Yeah.
Today, I don't think demonstrating Pythagoras theorem will be that interesting.
Yes.
Yeah. So today, I mean, today meaning, I mean, talking about a child who is coming to school today, who is going to come out 15 years, 20 years from now. We need to rethink. That's what I'm saying, that we need to rethink these things completely. The fundamental notions are same. That is, people need to touch, people need to think, I mean, hands on, minds on. There is no doubt about those things. I mean, they are all fundamentals, like alphabets. Okay. Some amount of memorization of multiplication table, yes, required. I mean, otherwise you won't be able to function. Fine. All those things are fundamental. Beyond that, what is needed is some interesting ways of looking at new issues. What about the kth nearest algorithm? It's one of the most used things in the today's, let's say, artificial intelligence programming algorithms, right? So can we have some activity where the k will be increased and decreased on how things are changing? No. Yeah. So these are key questions. When we are asking these kind of key questions, for example, that's where the social issues come into picture. Let's say, for example, I develop a algorithm. I'm a banker and I develop an algorithm whether to give loan to a particular person or not. So I'm looking at, let's say, some historical data. In that historical data, I find some factors by which there is a classificatory system that I can make, where I can classify a person as reliable, unreliable, somewhere in middle, those kind of things. So, but in historical data, there is bias. Because in the past, it's not as if that all those people who deserved got loan. I mean, if you walk on the streets of London, you will find quite a lot of undeserved people who have not returned loans are walking there, right?
Yeah.
Yeah, they are sitting there, right? Huh?
They've
So,
all
so
gone.
the social biases in the historical data also we need to bring in. That's what I was saying, that while we are talking about this, how this issue is also important. Otherwise, we are going to have a very, I mean, after all, we are looking at education to make society more humane, right? That aspect also we should not forget. We are not only looking at education to make somebody smart, efficient, that's part of it. But more important is we want to make the education to make the children humane, right? As a human person. So this aspect also we need to keep in mind. This is where, I mean, we need complete rethinking. That's what I just wanted to add. Sorry. I'll stop my share. Thank you.
Yeah, I just wanted to add one small for everybody to think about. It means the skills we need will be needed to complement the work of a computer. What the computer can do, we will have to turn into collaborator with computer. Means we will have to start learning collaboration with computer, that something computer does for us and rest of the things we do, like analyzing what is done and finding out more and more intuitive thinking, which will require human touch, that kind of thing.
So machine and
Can I
man should be
slightly
able
make
to
it
come.
different? Sorry for
Okay,
interrupting.
sure.
Slightly, I will make it different. What I would like to say is that it's not like skills we need to become, make the computer our collaborator, but skills we need so that the computers are in the name of computers, we don't become slaves.
Okay.
Computer are there to support us rather than we are supporting computer.
So
how to be the master of things. That's what I think.
Right.
So the example which you shared about data is very interesting, and I was just able to recall one example. So it was shared by somebody while observing the date of birth of a particular decade. It was found that everybody in that particular decade or a few decades, 20-30 years, all of them, 90% of the people, they were born in the month of, in a particular month, say in the month of March. And it was very surprising that how it is possible that in rest of the 11 months or the 10 months, the number of births were less, so drastically less. And then the reason found out was very interesting. The reason was कुछ पहले स्कूल में जब डेट ऑफ बर्थ लिखवाना पड़ता था बच्चों का, तो कोई एक पर्टिकुलर डेट थी, सपोज ऐसा था कि 31 मार्च तक इस एज का हो जाना चाहिए, तो डेट ऑफ बर्थ के सर्टिफिकेट्स तो लोग बनवाते नहीं थे, बहुत ज्यादा डॉक्यूमेंटेशन उस समय नहीं थी, तो लोग तो सोचते थे राउंड फिगर में लिखवा दे ताकि वो उस पर्टिकुलर 31 मार्च को बच्चा 5 साल का नजर आए। तो वो हिसाब लगा करके वो एक पर्टिकुलर मंथ में, और ये अभी कुछ साल पहले ही हुआ है कि शायद ये इलेक्शन कमीशन के डेटा में आया या कहीं किसी आईआईटी में किसी टॉक में बताया गया था, somebody has shared me। तो डेटा हैंडलिंग और डेटा एनालिसिस बड़ा इंपॉर्टेंट है, और बहुत सारी चीजें ऐसा हो सकता है क्योंकि कंप्यूटर ये तो पकड़ सकता है कि एरर हो सकता है इस डेटा में, लेकिन वो एरर क्यों है और किस वजह से, ये तो मुझे लगता है कि दिस विल बी डन बाय अस ओनली। इट इज द हियर द ह्यूमन इंटरवेंशन इज रिक्वायर्ड। सर, तो मैं अब आई वुड लाइक टू अंडरस्टैंड कि वी से दैट मोस्ट ऑफ द न्यू नॉलेज डोमेन्स दे आर बेस्ड ऑन द डेटा। डेटा एनालिटिक्स की बात बहुत ज्यादा हो रही है, मशीन लर्निंग और आर्टिफिशियल इंटेलिजेंस में भी शायद डेटा काफी यूज हो रहा है, तो या कोडिंग अभी हम बहुत ज्यादा यूज कर रहे हैं, तो कोडिंग और डेटा हैंडलिंग ये सब डोमेन्स किस समय किस लेवल पर स्कूल में इंट्रोड्यूस होना चाहिए, और उसका जो अभी एग्जिस्टिंग जो हमारा अभी करिकुलम है उसमें जितना क्वांटम है उसको हम कैसे इनहांस कर सकते हैं? या कैसे इम्प्रोवाइज कर सकते हैं उसको? डॉक्टर Venkatesh, would you
Yeah.
like to answer?
No, I think I'll wait for others to also react. No?
I think वो डॉक्टर पांडे कुछ प्रॉब्लम हो गई है शायद उनको.
Oh, I think he dropped out.
Is he-
He dropped out.
Like drop
He has sent me some
मुझे
message.
लगता है कि कुछ चीजें तो हमें करिकुलम में इंट्रोड्यूस करनी पड़ेंगी, जैसे कि प्रोबेबिलिटी का ऐसी प्रॉब्लम्स जिनके मल्टीपल आंसर और वो आंसर वेरी कर सके. वो टाइम चले गए जबकि हम एक बच्चों को बॉडमास का रूल बता देते थे और फिर वैसे ही वो कैलकुलेशन करते थे और उस प्रॉब्लम का एक ही आंसर होता था. तो वो जमाने चले गए. मुझे लगता है कि that particular decade is over now. So we will have to, teachers will have to reinvent themselves and find out problems which have multiple answers depending on various situations. And secondly, mathematical communication is going to become very important. Whatever you think is important, and as TVV said, whatever communication you have received, can you analyze it mathematically? Can you see an advertisement and realize that a false claim is being made? Can you look at the data and realize that the data doesn't seem to be correct, or whatever data is flowing in on the internet, which one seems to be more accurate? So mathematical communication, and even whatever data you have collected, whatever pattern you have seen, how do you communicate it to others so that other people also understand? And because you are working in a team, so communicating to the team and understanding from the team will also become important.
Sanjay has raised his hand. I think Sanjay, you can ask your question.
Yeah, good evening, good evening, everyone. My question to the experts is that usually when we teach tables to the students, we say 2 2s are 4. I just wanted to correct it and just wanted to share and wanted to ask all of you, it's not 2 2s are, 2 2s are 4. Usually we say 2 3s are 6. 2 3s are, it's not za, 2 3s are 6. So I just wanted to just have, anybody can comment on it?
No, you are absolutely.
Yeah.
Yes, because we usually say 4 2s are 8. 4 2s are 8. That is the correct pronunciation, like Dharm Prakash sir said.
Maybe what has happened, Sanjay, that R becomes Zar.
One second.
Yes.
Actually, that R is very silent kind of thing. R is silent, and in India we have habit of calling it R.
Yes.
So somebody have
in the textbooks too.
My daughter asked one question, Anita ji.
Hanji.
He always asks ki, Mama, when some letters are supposed to be silent, then why do we write them in spelling? Now I have no answer to this. If they are supposed to be silent, why do we read them in spelling?
So ये तो कोई linguist ही बता पाएंगे. हम मैथमेटिक्स वाले तो शायद मुझे लगता है कि नहीं बता सकते हैं.
Can I just again share something and talk?
Madam.
Yes, Uma ji.
Yes, Uma ji.
Madam, here I would like to ask a question to clarify my doubt. At primary level, while teaching multiplication, usual multiplication we do. Besides that, I teach students a lattice method also. But in exam point of view, since there are parallel teachers and head of the department, they say that you can teach as activity, but when students bring the lattice method in the exam, they are not ready to accept, ma'am. What to do for that, ma'am?
I can answer you this. I think your co-teachers and other staff need to understand all these alternate algorithm. The purpose is to calculate, right? And now what path do I take to calculate? That doesn't matter. When a child reaches in class 10, what do I expect from them? Use tricks, do this method, do that method. But at primary education, we force them to use standard algorithm, which is wrong.
Yeah, that's what I used to teach them many methods. Even for division like that, I used to teach a dot method. So children enjoy that actually. When I say that do not use in the exam because HOD objects, I say that no, ma, you cannot use it for exam as an attend. Yeah, they ask me why, ma'am. Then why are you teaching that method?
Umaji, I have a suggestion.
Yeah, tell me, ma'am.
In the year beginning, all the department teachers, they shall sit together and they shall write what is the primary objective of teaching a particular concept in the class. Why we are teaching that concept, what should be the final outcome, and then why actually we want to introduce alternative methods. What exactly we want to show them by introducing those alternative methods.
Right.
But
So
what
if
I
this
do,
objective is clear, we will be very clear while assessing them that how to assess and what to assess.
But what I do when students apply lattice method in exam, secretly I give mark, ma'am.
So in this context, I want to understand.
We will have to even overhaul our assessment system.
So in this context, I would like to ask Dr. Venkatesh also, and the teachers can also reflect on this. What kind of teaching skills are required? Because some kind of refurbishing of teaching skills is also required if we really want to change the whole scenario.
Yeah, thank you, madam. Thank you, sir.
Dr. Venkatesh, can we have your opinion about this?
Yeah.
Please,
Number one is, I think, I mean, teachers, we learned quite some time ago what we know. And of course, some of us make some effort to learn new things. So if we are looking at the emerging challenges, emerging opportunities, whichever way we want to see it, then teachers also need to undergo some amount of, or rather a significant amount of relearning. Yeah. So if it's one thing to make a very good textbook, the other is to see that the teachers understand the spirit of it and then transact it in that way in the classroom. I mean, we know from experience that problems in that, of course, problems will always be there, but we should make some better effort when we do this time, that teachers are prepared to this before we actually launch it. That's one challenge. Just let me share two things again, if it's okay.
Yes.
Like you mentioned about, let me first take it out so that otherwise it won't come. Yeah, okay, let me share now. Once again. Just, yeah, I think now I'll be able to share. Yeah. So you talked about birth months of people, right?
Yeah.
Yeah. So here is the figure from huge samples that have been collected. Peak birth month by latitude. No, just wanted to say that, see, for example, even open-ended questions like that can lead to interesting discoveries.
Yes.
So this is a kind of skill that we need. I mean, imaginatively ask certain kind of question, explore, find out, from surrounding. This is one. Second, I also want to share one more thing, one more aspect. Just give me a second, because before sharing, I need to. Yeah, now I think it gets shared. So here is a very simple tabletop model. That is, if I have a shark and then there is a tuna, and the shark has to eat so many number of tuna to survive. in a particular ecosystem, how many tuna and how many shark will balance, will be a sustainable population.
Very interesting.
Yeah. So now, is this a mathematics problem? Is it a biology problem? Yeah. So
whatever
I think,
problem it is, but we shall be able to accept all the responses from the students.
Yeah.
Whatever kind of responses they are giving, if they are able to explain their thinking, we shall be ready to accept everything.
Yeah, if they are able to explain logically.
Logical.
Logically, whatever they have discovered and they have calculated, then that answer should be accepted as correct. Not as Uma said, the rest of the teachers don't accept the latest method or whatever method. The importance is not method, but the mathematical thinking behind the solution.
और कोई अल्टरनेटिव मेथड भी यूज कर रहा है तो मुझे ऐसा लगता है कि इस बात को भी अप्रिशिएट करना चाहिए कि इस बच्चे ने एक एफर्ट किया एक स्टेप एक्स्ट्रा जाने का, कुछ एक्स्ट्रा सीखने का, वो भी तो एक तरह का एटीट्यूड टुवर्ड्स द सब्जेक्ट है.
And going beyond obvious, or going different from what crowd is doing, that is also, I think, one decision that child is taking.
डॉक्टर वेंकटेश, ये जो प्रॉब्लम्स आपने शेयर करी है, पहले तो आप हमें इनका सोर्स बता दीजिए. हाउ द टीचर्स कैन गेट दीज काइंड ऑफ प्रॉब्लम्स, बिकॉज टीचर्स आल्सो नीड एक्सपोजर टू सच काइंड ऑफ प्रॉब्लम्स.
Yeah. See, this one that I was sharing, it's a paper which talks about biology undergraduates, dynamics to biology undergraduates.
Okay, mathematical biology education. Great.
Yeah.
Okay. So on this same question, would you like to say anything, Khushbu, about the change in the kind of skills teachers required nowadays?
Definitely. I think, we are trying to bring change in our schools. We are trying to bring change in our curriculum. But what I see as a challenge is our teachers are not prepared to take that change. We need to prepare our teachers also. For example, NCERT class 1 to 5. I think wonderful book. The thought behind that one need to understand. And that is something not oriented. And I keep on hearing, such kind of NCERT math books. Those are not math books. And I keep on telling everyone, see, those math books are created keeping in mind what is missing from our mathematics classroom. You need to understand what is the purpose of that math book. You know maths, you know content, you know how to get the problem solved. But what was missing is contextualization, storytelling. And student enjoy story a lot. So recently I was having one conversation with one of the person, and I asked that person, he is trying to launch some courses in Bangalore. He is hiring a campus, and artificial learning, data science, and flight maintenance, those courses he is going to launch. So I said, why are you not thinking about pre-service course? I feel our pre-service teacher training need to improve, because pre-service teacher training is going on the same curricula, whereas in service or our classroom expectations are changing. So I think this has to go. It's a vicious circle. We need to look at every aspect of that. We need to prepare our teachers for the same, and teachers understand. The only thing is they didn't get that kind of exposure, so a written document won't help them. They also need to experience such kind of approaches to learn so that they can implement.
Right. Sir, any final remarks, or if any participant, 3 participants has raised their hands. So quickly we can ask them to unmute themselves and speak one by one. Mr.
Yeah.
Devraj.
Yes, good evening, madam. Okay.
Good evening.
Thank you for this organizing this wonderful program, right? And I would like to point out 2 things. See, when you look at even internet or just search it, Google, who invented zero? The Google will give the answer that Aryabhata invented zero. But we can't, if you apply your logic, you can't accept that answer. So well before Aryabhata, it was there in practice also. So this is what the kind of logical thinking we have to brought into our curriculum or to the thinking of our students. So many students and even many books refers that Aryabhata invented zero. So we have to think logically. Okay, as TVB said, yes, we have to bring in that culture. That is very, very important. Now, again, when we are talking about artificial intelligence and coding and all, people and many parents think that, okay, the math tables is not required. Addition, subtraction is not required. Only we have to learn the coding. See, the fundamental thing is this algorithm or the process, how we have to do this. Okay, when you are clear about that logic and reasoning skills, yes, then you can do the coding and this. Okay, this is what we have to bring in. Then again, coming to the textbook, in the primary textbook of NCERT, we are spending at least 3 chapters on Roman numbers. Is it required? This is what I have to point out or raise. Thank you.
Okay, right. So before Sanjay, somebody else has also raised the hand. I'm not able to see right now who is there.
I think Umaji already asked her query. She
Acha,
forgot to put
okay.
it lower, so
Okay,
she lowered
okay.
that.
Sanjay, you want to add something? Romanji, want to say something?
Unmute yourself.
Namaskar to everyone, and it was a real very interesting session of questions and trying to find solutions. In reference to, I would like, there was some talk about zero, and so I am just reminded of what I used to talk about it in my classes. In my classes, high school classes, I told them that the same thing, that the zero did exist. शून्य है, मगर शून्य को नाम zero देना और उसको symbol zero का बनाना हम आर्यभट्ट को नाम देते हैं. But I just used to give an example, and that used to be that if you have a small infant, मान लीजिए आपके पास 8-9 महीने का 10 महीने का एक बच्चा है छोटा सा, आपने थोड़ी सी चॉकलेट्स पकड़ी और उसको थोड़ी सी टॉफीज उसके हाथ में दी आपने, 4 or 5 of them. Now ask कि दे दे, हम अक्सर करते हैं, बच्चों के साथ खेलते हैं ऐसा, तो वो एक दे देगा, दूसरे भाई बहन को भी दे देगा, वो करते करते मतलब बहुत generously सबको दे देगा एक एक करके. Now after that, once that one toffee or a chocolate is left in his hand, अब आप उसको मांग के देखिए कि दे दे. And believe me, the brain of that child knows कि इसके बाद I will have the nothing. So I used to tell my students that the concept of nothingness is there in your mind already, but we give it a symbol for our study purposes, for our learning purposes, for its usage purposes. That comes later, but the mind is already equipped with the knowledge of shunya, with the knowledge of, zero. So these type of things need to be discussed with the students so that they can talk about mathematics, and that will make it more interesting for them. It will make it more useful for them. They will also become thinkers. They will also history of mathematics. बच्चों को पता ही नहीं होता क्या होता है. तो अगर आप टॉपिक करवाते हैं तो टॉपिक के साथ आप किसी relevant history को बताते हैं, कैसे कोई टॉपिक originate हुआ. So I always used to do that origination of the topic. So when you talk about that, they get interested in it. That okay, this is how some new kind of thinking can be done, and this is something to be promoted in our students. I feel so.
रोमन जी, ये इंटरेस्टिंग है कि जीरो आप ऐसे एक्सप्लेन करते हैं, लेकिन मुझे लगता है जो ज्यादा अप्रिसिएशन जीरो की होती है वो इस कॉन्टेक्स्ट में होती है कि
placeholder,
because of the place value and the decimal number system we can
Pinkalacharya has been explained.
there is a video of Vigyan Prasad.
Pinkalacharya has been explained the same thing in explaining
decimal system. Yes.
Right. That is
so its utility is so important.
300, yeah. And even in the Bhattali manuscript, we can see the encryption of zero, right?
Yes, that's it.
So there's a video of Vigyan Prasad which I always use, and I really love that video on number sense, the math factor show that used to come. I think that is a wonderful video to reflect on history of mathematics. If you all can get a chance, search on YouTube. It is a
and the person behind creating that
is here.
video is here. Dr. Venkatesh is there.
So amazing videos of math factor. So I would like to thank you for those
Thank you
videos.
so much.
DVB is
So-
done his PhD in history of maths only, right?
Yeah.
Uh, I think this is interesting because when we all started speaking, that means that we all are now geared up to take up the challenges, and we are also ready to bring the change. So thank you very much to all of you for joining us today. And my special thanks to Dr. Venkatesh, kyunki,
Right.
ji,
Thank you.
and Khushbu and Dr. Pandey and all of you. Thank you so much.